Hello everyone. Today we are working on finding limits analytically with algebraic analysis. So consider the function below to find each limit. If a limit does not exist, state why. This is a piecewise function, g of x, and I have restrictions x less than -2 and x greater than -2. And the A, B, C questions are asking me limit x approaches -2 from the left, from the right, and from both sides. Okay, so part E is, and what do we do? First thing, we plug in. That's the first step, we plug in. If we get 0 over 0, we need more work. What is more work? You should watch the other videos that I have. The first step is plug in. If you get 0 over 0, then you need more work. Which means least common denominator, factor, distributive property like distribution. There was conjugate if you have a square root. Second one was if you get number over 0 after you plug in and you get number over 0, then you are picking arbitrarily close number from the left, close number from the left and right. And then you will decide, and you know the answer must be positive, negative, infinity, or does not exist. Either does not exist, either one of them. Okay, so I'm doing plug-in first. So I'm doing x approaches -2 from the left. From the left means I can't use both of them for the left, okay? If you see, this one is x less. Less is always goes left. X greater, the alligator mouth towards x. So x greater means that's the right. So let's pick the left of -2. So what I'm gonna do, I'm gonna use this function, this piece of the g of x function to plug in my -2. So let's plug in that. I have equal to -2 squared plus 3 -2, and it's giving me 8 minus 6, which is equal to. So the limit x approaches -2 from the left is 2. Let's try x approaches -2 from the right, and from the right I'll use this piece of the information because that's what the restrictions are for this one. So this one is going to go -half, -2 plus 1. This is giving me, this one is giving me negative times negative is positive, and it's 1 plus 1 will give me 2. Okay, so the right side limit is also 2. Now, since we already got left and right limit for x approaches -2, then our answer is limit. This is equal to, because limit x approaches -2 from the left of g of x is equal limit x approaches -2 from the right of g of x, and both of them are equal to. So it means we're good on this one. Let's try find each of the following limits analytically, show your algebraic analysis. So again, the first thing first, direct substitution. So I'm going to direct substitute e, limit x approaches e ln x over 2x. So I'm ln e over 2e. Now, ln e is always equal 1, okay? So you can write down your important information up here. It says ln e is always equal 1. So ln e is 1, so it's going to turn 1, and that's 2e. and I can't do anything with it. I'm not using a calculator. If you want to, you can use it and get the decimal answer. 3 decimal places, by the way. I'm going to leave it alone. Limit x approaches 5 from the left of 2/5 x squared plus 2x. So it's from the left, and I'm going to do direct substitution first. If we need more work, I don't think so we need more work because it's not a rational function. But let's see what happens. 2/5, and I have 5 squared plus 2 of 5 equal 2/5. 5 times 5 is 25 plus 10. Now when I solve this, I know I can simplify these two. So that will be 5 times 1, 5 times 5, 25. 5 times 2 is 10. 10 plus 10 is going to give me 20. So the limit x approaches 5 from the left is 20. Okay, let's go here. Limit x theta approaches pi. Sine squared theta plus 2 cosine theta. Now make sure that you remember this. When I see the square on top of sine, it means sine theta is on the whole function. If this 2 was on the theta, then it means that's what it is, sine theta squared. But if the square is on top of any trig function, then it means you have to rewrite it like that. So I'm going to rewrite it, and always rewrite it. This is very important. Sine theta squared plus 2 cosine theta. So now let's do direct substitution here. If I do direct substitution, it's going to give me sine pi whole squared plus 2 cosine pi. Now, what is sine pi? So I know this is right there, pi, and sine means a y value, so the y value is 0. So this thing is 0 squared. What is cosine pi? That's pi, cosine is -1, which is an x value. Cosine is x value, and -1 is right there. So it's going to give me 2 -1, because cosine pi is -1. Then I'm getting -2 as an answer. For limit x approaches, theta approaches, pi is equal -2. Okay, let's go part D. Again, part D, do you see the tangent? And since I'm going to need my unit circle, then I don't have any tangents here. I have sine and cosine because order pair is x and y, so tangent is not there. So you have to rewrite this as an identity. The tangent identity is always equal. Tangent, just make it x, I guess. Tangent x is equal sine x over cosine x, and that's the identity for the tangent. So we need that. I'm going to rewrite this as sine x over cosine x so I can use my unit circle. So I'm going to rewrite it. It's equal. I have sine alpha over cosine alpha, and this is the big division, which is this one I'm talking about, a squared. I think it's alpha squared, sorry. Look like a, okay, that's what it is. Now let's do direct substitution. I have sine 5 pi over 3 over cosine 5 pi over 3, and the big fraction is right there, and it's 5 pi over 3 whole squared. And it's equal. Let's try what is sine 5 pi over 3. Find 5 pi over 3 first. So my 5 pi over 3, this is 5 pi over 3 right there. And what is sine? Sine means a y value. So negative square root 3 over 2. Negative square root 3 over 2. Okay, then what is cosine 5 pi over 3? It's half. So I'm going to make half. And I have a big fraction again. And 5 pi over 3 is going to, if you square it, it is going to give me 25 pi squared over 9. Okay, let's fix this. It's not that hard. It looks like that, but it's really easy. So I have equal negative square root 3 over 2, and I'm changing this division into multiplication, and I do the reciprocal of that one, which is 2 over 1. And that one, let's leave that one in the bottom. Let's figure it out the top portion first, okay? And I have 25 pi squared over 9. Let's fix this. Straight across you multiply, it's going to give me negative 2 square root 3 divided by 2. And that one now I can change again this into multiplication and reciprocal, which is 9 over 25 pi squared. So what do we do now? The 2 and 2 you can cancel out, the 2 and 2. So I'm left with, it's negative, this is negative. I was just checking if the half is negative, like the x, the cosine, but no, it's positive x. So I have negative 9 square root 3 on the top. In the bottom, I have 25 pi squared. And I can't do anything with this, so I can simplify it further. So I'm gonna leave this alone, and that's my answer. It was not that hard. It's just the fractions when you get several times, these lines, just be careful on those and do one step at a time. Okay, let's try question E. Again, direct substitution is the thing that we're gonna do. So if I plug in negative 2 here, negative 2 is gonna give me 4. Positive 2 minus 6. It's going to give me 6 minus 6, which is 0. I'm doing this in my head. You can use a calculator. Negative 2 times 2 is negative 4 plus 4 is going to give me 0 over 0. Okay, so we need more work, which means this is a quadratic. I have to factor out. I can also find a common factor here, which is 2. So we need more work. And this is how you're going to do on the AP test if it's pre-response question. So I plugged in, I got 0 over 0, now need more work, factor out this. It's gonna be x plus 2 and x minus 3 over 2x plus 2. Just pay attention, and if you don't know how to factor, then please comment below, and I will upload in the AP Calculus AB playlist how to factor, okay? But you just find 2 factors of this, 2 factors of this, and make sure when you get the factor of this, either you add or subtract those 2 factors and get this number, which is technically, this is 1. So I'll show you how to do that if you comment below. Now they cancel out, which means x plus 2 equals 0, which means x equal negative 2 is a whole in the function. So I'm left with x minus 3 over 2. Now I'm going to plug in negative 2 in here. Negative 2 minus 3 over 2 is going to give me negative 5 over 2. So that's my answer for this one. Okay, let's go question F. Now, if you pay attention that one, I'm going to plug in 3. I am getting, look, 3 plus 5, 5, 6, 7, 8. And 9 minus 9 is 0. So I'm getting undefined, which means arbitrarily close from the left and from the right of 3. That's what we are going to do. So let's try. I'm going to get limit x approaches 3 from the left, and the function that I have is x plus 5 over x squared minus 9. What is left of 3? If I draw a number line, and this is the 3, so left, and this is 3, that's here 0, that's 2, that's 4, for example. So if I'm going left of 3, it means I'm picking up here 2.9 or 2.009 or something. But I picked like really close to 3, which is 2.9. So plug in 2.9 here, 2.9. Okay, when I see this undefined, before I go there, guys, when I see the undefined, then I already know that my answer is positive, negative, infinity, or you can write does not exist. Either way is good. You see that? So that's what I'm trying to see. So if I pick 2.9 plus 5 over 2.9 squared minus 9, this is giving me positive number. You know, for the answer, if we have positive and negative, infinity, or does not exist, we are not interested in numbers, we are interested in signs. So that's positive. If I do this, 2.9 square subtract 9, so it is going to get, 9 is a bigger number, so it's going to give me negative. So technically I have negative infinity up here. Let's try limit x approaches 3 from the left, x plus 5, x squared minus 9. So plug in from the right side. So I'm going to pick 3.001 or just 3.1, very close to 3. So let's do 3.1 plus 5 over 3.1 squared minus 9. This is going to give me positive. And this one I think is going to give me positive too, because 3.9 squared is going to give me 9 point something, which is greater than this 9. So I'm using that sign. So it's positive infinity, that one. Which means the limit x approaches 3 of x plus 5 over x squared minus 9 is equal does not exist. So that's what it is. If they were positive both, or if they were already negative both, the infinities, I would still say does not exist, because the limit needs a y value. Like x approaches to something, we are looking for the y value where the x is approaching, right? And if you don't have a real value for y, then it means does not exist. Let's try this one. I'm going to give you something really good to remember for the cubic function, and also like I have to write it down, and so you would be able to remember it. Okay, if I have a cube minus b cube, then it's gonna equal a minus b. Okay, a minus b, you pick the same thing as it is in the second factor thing. You're gonna go a squared, but instead of negative, you're gonna have a positive sign, plus ab, like you put them together, a times b. The second sign is always b, so it's gonna be b squared. If I have a cube plus b cube, you pick that as it is the first time. The second, you go a squared and you make a different sign. If it's positive, you do negative ab, and the rest of the stuff stays together. These two stays positive all the time. If you pay attention here, if I plug in up here direct substitution, like 3 over 2 and what is it, 3 over 2 I think, and then I'm getting 0 over 0. When I plug in 3 over 2 direct substitution up here, it's going to give me 0 over 0. So I need more work, and I can factor out, which since this is a cubic function, then I'm going to use my really quick strategy to solve this. So I have to rewrite this like a cube minus b cube, okay, just like that. Okay, 8 is a perfect cube, which means it's 2. 2 times 2 times 2 is going to give me 8. 2x cube minus 27 is 3. 3 times 3 is 9. 9 times 3 is 27, so it's also a perfect cube, over 2x minus 3 stays as it is. Now it look like this, so I can easily solve that. I'm gonna pick 2x minus 3 as it is, okay, 2x minus 3, and then I have inside is a squared, which means this is my a, so it's gonna be 4x squared, right, plus ab. Ab means I have to multiply these two, so that will give me 6x plus b squared means 9. 3 squared, that's a b, okay, that's this is A, over 2x minus 3. This cancel out. Now, if you pay attention, they cancel out, which means there is a hole in the function. Where is the hole in the function? I'm repeating this because I don't want you to forget this. So it's going to give me x equal 3 over 2. So at 3 over 2, x equal, that is a hole in the function. Okay, so I'm left with this. Now let's do the, I did the factor, I did the more work. Now I'm going to plug in 3 over 2 one more time in this equation. So it's going to give me 3 over 2 squared plus 6 3 over 2 plus 9. When I solve this, it's giving me 9 plus 9 plus 9, which is 27. So my answer is 27. Guys, memorize this because since the AP calculus test is time test, so it's really good that you know this and you can quickly do it. Okay, question H. Direct substitution is the thing that I'm gonna do. If I plug in -2 here, I'm doing it in my head and you watch, guys. If I plug in -2 here, -4 plus 1 is 1. 1 is a perfect square, so 1 minus 1 is 0. If I plug in -2, so it's going to give me 0 over 0. Again, I need a more work, and since I have a square root, I'm going to do a conjugate. So I'm going to erase this. You already know I got that 0 over 0. Conjugate times, you have to just change this sign. This is outside the square root. The inside square root, you don't touch that. So it's going to go 2x plus 5 square root plus 1 over 2x plus 5 square root plus 1. So that's my conjugate. So let's distribute, multiply top and bottom. The bottom you don't touch. You just put them in parentheses as multiplied. But the rest of the stuff, we have to figure it out. So what I'm doing, I'm going to multiply these two. When I multiply square and square, you know I'm going to get, this is limit x approaches -2, and I have 2x plus 5. When I multiply this with 1, I know I'm going to get that. If I multiply -1 with this, I know I'm going to get negative of this. So they cancel out each other. Let me do this. Okay, let me do this in the scratch paper. This is my scratch paper, okay? And I'm going to do it in red. If I multiply, it's going to give me 2x plus 5 square root. When I multiply 2x plus 5 with the 1 right there. So it's going to give me 2x plus 5. Now, I'm going to multiply -1 with this, so it's going to give me -2x plus 5 square root. You know they cancel out. That's why I just don't want to mention it here. You will get used to it, and then next time you don't do this, like you do it in the head and just ignore it. -1 times +1 is going to give me -1 over this whole thing. It's going to stay as it is, like x plus 2 with the within the parentheses and 2x plus 5 in the square root plus 1 in the parentheses. That's what it is. Okay, what else I can do up here? I can simplify this. It's going to give me 2x plus 4, and the rest of the stuff stays. X plus 2 and 2x plus 5 plus 1. And please remember this, in calculus, the denominator, you don't solve it. Just leave it alone. It's going to be okay. Then common factor is 2. It's going to give me x plus 2 over x plus 2 again. I know it's annoying when you keep writing the denominator, but we don't have a choice. We have to do that. Cancel out. And that's where is the hole in the function? X equal -2 is a hole. So what is left? I have limit x approaches -2. And guys, if this question was free response, then you have to do it the way I'm doing, like limit x approaches -2 every time. You have to write down this. Then I'm left with 2x plus 5 square root plus 1. Now plug in -2 again. When I plug in -2 again, that will give me 1 plus 1, and 2 divided by 2 is going to give me 1. Okay, let's go to the next question. It's I. And if you plug in, again, I'm going to do it in my head. If I plug in 1 here, 2 times 1 is 2, 2 minus 1 is 1, 1 square root is 1, 1 minus 1 is 0. So I am getting 0 with 0 again. So I need more work again. Okay, I'm going to erase that. I have times, and again, it says a square root, so I'm doing conjugate. The outside sign you change, but inside the square root you don't. So I have 1 plus 2x squared minus 1 in the square root, divide by 1 plus 2x squared minus 1 in the square root. Now I'm going to go distribute. 1 times 1, okay, I have to write this first. Give me limit. I have to write this as a free response question, so you get used to it. Approaches, limit x approaches 1. Yeah, it is 1. Okay, limit x approaches 1, and I'm going to multiply 1 times 1, which is going to give me 1. 1 times 2x squared minus 1 square root is going to give me 2x squared minus 1. Then I multiply 2x squared minus 1 with this one, because I multiplied 1 first with both of them. So when I multiply 1 and 1, I got 1. When I multiply 1 and this, I'm getting that. I'm going to write it in this. I think let's erase it and write it down. So I got 2x squared minus 1 in the square root. I got that. Now this one, I'm gonna multiply this with 1 right there, and it's gonna give me negative 2x squared minus 1 square root. So you know they cancel out each other. And this is also going to multiply with that. Different color. This is also going to multiply with this, right? Which is going to give me 2x squared minus 1, because if you square the square roots, they cancel out. So I'm left with 2x squared minus 1. So let's try that. Go back. I have 1 minus 2x squared minus 1. When you have minus up here, be careful, put them in parentheses, because this minus is going to distribute. In the bottom, I'm going to keep everything as it is, like we did for the other one. 1 plus 2x squared minus 1 square root close. Now let's distribute this. Limit x approaches 1. 1 minus 2x squared plus 1. So I have again the same thing, x minus 1. And you have to do this, guys. I'm keep saying this. On the AP test, this is very important that you give them step by step. Limit, don't skip any step. This is going to give me 2 minus 2x squared over, right? Yeah, that's plus 1. So this is what it is. X minus 1, and I have 1 plus 2x squared minus 1 square root and close. Now, I'm going to take out the factor thing, like 2 is a common factor here. So 2 is a common factor. I'm left with 1 minus x squared, right? Over x minus 1 again, and I have 1 plus 2x squared minus 1 in the square root and close. Now, I could cancel out one of those, but I can't because their signs are different. You see, it's a positive x, that's negative x. That's positive 1, that's negative 1. So is there any way I can change the sign of the top portion so I can make it like that? Like make the positive x and make the negative 1. So if I can do that, then I can do the cancellation there. And technically, I can. I'm going to show you that. I have limit x approaches 1. Then what I'm doing, I'm multiplying this by negative, okay? So I have negative 2 x squared minus 1. If I multiply by negative, then this one turned negative and that one turned positive. Do you see that? And then I have in the bottom, again, the same thing, x minus 1 1 plus 2x squared minus 1 square root and close. Limit x approaches 1. Then let's open this up, this x squared minus 1. So I'm going to go negative 2x plus 1 and x minus 1 over x minus 1, 1 plus 2x squared minus 1. X minus 1 cancel out. When it's x squared minus 1, it means you have to do one positive, one negative. So they cancel out, and I'm left with limit x approaches 1, negative 2x plus 1 over this 1 plus 2x squared minus 1 square root and close. Now this whole thing is like that, right? So that's what I got so far. Now I'm going to plug in my 1 here. So if I plug in 1, it's going to give me, I'm going to use a different color, it's going to give me negative 4. And I plug in 1 here, it's going to give me 1, square root 1 is 1, 1 plus 1 is 2. So the answer is negative 2. Now you can go really slow and do it yourself, however it makes sense to you. Okay, now I have JKLM for more questions. Okay, in this question, what I'm doing when I plug in the direct substitution, if you guys pay attention here, when I did the direct substitution, I got 1 over 0 here. That's 0, and then 1 over 0, and this one was 1 over 2. When you plug this in the calculator, it will give you an error because you can't add undefined function with the fraction, with the defined function. You can do that. So it's going to give me error. So what I did, I said, okay, let me figure it out, solve this. It doesn't mean that my answer is undefined because I'm not getting anything. You know that I'm not getting number over 0 or 0 over 0. So what I did, I try to solve this fraction. Like I do the least common denominator and all that stuff. So what I'm going to do, I'm going to find least common denominator for this. And the least common denominator in this case is x plus 2 and then x, right? This is least common denominator. Now solve, multiply straight, multiply, what is it called? Butterfly. Do the butterfly multiplication. So it's going to give me x plus 2, right? Then I have to solve this further. It's going to give me 2x plus 2 over x plus 2 and x, right? Like this. And then we still have that big, and I'm going to make it like in different colors so we don't get confused. And I have the bottom is x, it's going to stay x. Now what else I can do up here? 2x plus 2, x plus 2 times x. And since this is x, let's solve the problem as a reciprocal thing. So I have 2x plus 2 over x plus 2 in x times, since this is x over 1, then it's going to go 1 over x. What else I can do here? And by the way, you have to write like limit x approaches 0 every time, okay? So now I have limit x approaches 0. What am I getting here? I'm going to get 2x plus 2, the top, and I can this is like easy to do, the multiplication. So I can do, I know I told you not to touch the denominator, but something easy like this, I can do that. I got this. Now, if you pay attention here, I plugged in 0 here. I'm getting 0, number over 0 now. Do you see that? Which means I'm going to pick arbitrarily close of 0 from the left and right. So let's pick arbitrarily close. Limit x approaches 0. Did you guys pay attention? The first thing when I did the direct substitution, it didn't work. Like I said, I'm not adding undefined function. But when I solve this least common denominator thing, like two fractions, I solve them, plug in 0, again, I got number over 0. So now I'm going to pick arbitrarily close. So limit x approaches 0 from the left of 2x plus 2 over x squared x plus 2. So when I plugged in from the left, like pick negative 0.9, this is my 0. If I pick left, this is negative 1. I pick left of this, so negative 0.9. 0.9 times 2 plus 2 over negative 0.9 squared, and I have negative 0.9 plus 2. When I solve this, I got positive over positive, so it means I have positive infinity. Limit, and we already know when we get number over 0, it does not exist, or since they are talking about left and right both, I will just say does not exist. So I have limit x approaches 0 from the right, 2x plus 2 over x squared, x plus 2. When I plug in left, right of 0, I picked a number 0.001 plus 2, 0.001 squared. Okay, squared, and I got 0.001 plus 2. When I solve this, I'm getting positive infinity again, like positive over positive. So that's a positive infinity. Either way, limit does not exist. Limit x approaches 0 of 1 over or 2x plus 2 over x squared, x plus 2 equal does not exist, because we have infinity from left and right. Even if they are both the same infinities, like both positives, still limit does not exist. If they would ask me, limit x approaches only, not 0 from left and right, they are only asking me limit x approaches 0 from the left only, then I would say, okay, the limit x approaches 0 to x plus 2, like this function, equal positive infinity, you know. But when I have both, like from the both sides, I just have to say does not exist. Okay, plug in direct substitution here. When I did the direct substitution, I'm getting number over 0, because 3 times 4 is 12, and 7 times 2 is some 14 plus 2. I'm getting some number, but I'm getting 0 in the bottom. So in this case, I'm getting number over 0, which means arbitrarily close. And since they are only asking from the right side, I'm just going to give them from the right side, okay? So let's do from the right side. Okay, let's try. This is 2. Right side of 2, I'm going to pick, what do I pick? 2.1 up here, okay? So before I pick 2.1 and plug it in, I have to make sure the quadratic function, I have factors the bottom also. Make sure factor, what if there is a cancellation there? It will mess up the whole answer if there is a cancellation and we don't do it. So let's factor out. Again, I'm going to factor out this. So it's going to give me limit x approaches 2 from the right. I have 3x plus 1, and I have x plus 2. Then in the bottom, I have to factor this out because I'm looking for cancellation. It's going to give me, since it's minus, one is positive, one is negative. Okay, there. Then they cancel out. Did you guys see that? That's a whole, that's why every time when you have a question and you can factor out, do it with, I mean, before even you start anything, just factor it out, open it and stuff like that. I mean, after direct substitution, whether you get 0 over 0, then you, of course, you're gonna need more work. But if you get number over 0, I would still factor out the question to see if there is a cancellation. So I'm left with limit x approaches 2 from the right, 3x plus 1 over x minus 2. Now I'm going to plug in my 2.1 here. So it's going to give me 2.1 times 3 plus 1 over 2.1 minus 2. I know this one is positive because 2.1 is a bigger number than compared to that one. And this one is also positive. So it means my answer is positive infinity. And did you see, I didn't say it does not exist, blah, blah, blah stuff. But I just said, okay, that's a positive infinity because they are only asking one-sided. But if they are asking two-sided, I have to give them does not exist. Okay, I. Again, direct substitution. I do 3 times 2, 6, 6 plus 5, 6, 7, 8, 9, 10, 11 over 0. Again, 11 over 0, that's undefined, and we have to do arbitrarily close. So that's my 3, and right side 3, I'm going to pick 3.1, okay? So can I simplify this? I don't think so, like common factor or factoring, I don't have any. So I'm going to do x approaches 3 from the right side, and I'm plugging in 3.1, 2, 3.1 plus 5, and I have 3.1 minus 3. I know this one is going to give me positive, and this one is also going to give me positive. So which means my answer is positive infinity. Left. Now again, this is the same question, but it's from left. Left of 3 is this portion. So it means I'm going to pick 2.9 close to 3. So it's going to give me limit x approaches 3 from the left. 2 times 2.9 plus 5 over 2.9 minus 3. So the top portion is going to give me positive answer. The bottom is going to give me negative. So that's negative infinity. So my answer is negative infinity. Now, if there was a question like limit x approaches 3 to x plus 5x minus 3, then you know I have to give them from the left and from the right because I'm getting undefined, like number over 0. When I did the direct substitution, then I have to give them arbitrarily close left and right. And this is my right, that's my left. I get positive, negative infinity. Then I would say this is equal, the limit does not exist, because this means both sides, like, you know, this means both sides. So that's why I have to give them does not exist. Even if they are both positive or negative, still does not exist. But if they were asking only one-sided limit, then it's just leave it as whatever infinity or a negative or positive you get. Okay, so that was it. And then if you guys have any questions, please comment below. I will help you out. I can tutor you one-on-one on Zoom. You have to write down in the comment your name, and then I will do the rest of the stuff with you guys, tutor you one-on-one. Please like my videos, like the lessons, and subscribe my channel. Thank you so much.